So now in section 4.6, we're going to expand your abilities just a little bit, hopefully. First of all, starting with this new Forever card, Forever number 43. You guys saw yesterday the purpose of this card. A lot of you guys, when you first saw this, were like, wait a minute, hold on. We've seen these guys before, integral of tangent and cotangent. That's easy cheesy until we hopefully went through the example of integral of tangents, not so easy cheesy. What are the trig integrals that we do know from the basic rules? I'm going to go ahead and really quickly just make a new page. You guys don't actually have to write this. We're just doing a quick review. What are the basic trig integrals? Okay, yeah, integral of cosine. Let's do u du, just because we've been doing u's recently, right? Hold on, give everybody in your group a quick high five. Or someone next to you. Or someone diagonal to you. Make sure they're doing all right. Andrea, check in on Bridget real quick. Hang in there, kiddo. I know. Okay, help me out. Integral of cosine u is? Now u, sine of u. Let's see. What is the integral of sine of u? Negative cosine of u plus c. What's another basic one that we should know? Cosecant squared, that's one. Of u. Uh-oh, I don't know what I'm writing. Shh. No judgment. Okay, cosecant squared of u du. What does that equal? Oh, good. Negative cotangent plus c. Negative cotangent u plus c. What's another basic one I know? Secant squared u du equals to tangent plus c. Girls in the back are rocking it. Come on, the rest of my kiddos. Where are you? Basic trig integration. Are you just hiding? Keep going. Integral of cosecant or tangent. Yeah, these are the basic ones. These are the ones we should know by heart. Negative who? Cosecant. What else do we know? Good. Secant tangent. Who is that? Secant u plus c. Who is not on this list? Tangent is not. Who else? I mean in the sense of over here. Tangent by itself is not. Cotangent by itself is not. Secant by itself, not squared, is not. And cosecant by itself, not squared, is not either, right? These are the old school formulas. And just because these are basic does not mean that the ones that are missing are basic as well, right? So this is what you needed to have down from yesterday, and need to start memorizing now because they're tricky. He looks like he should be easy, but he's not. He looks like he should be easy, but he's not. Same with him, and same with him. But as with all trig rules, kiddos, is there a pattern of relationship between the tangent and the cotangent one? Kinda. Now one's a negative, one's a positive. But as we saw yesterday with these ones, where or who is tangent? Sine over cosine. And if you had sine over cosine, who would be your u, the top or the bottom? The bottom. So do you see why tangent should have ln of cosine, not sine? Because cosine is the u. For cotangent, who would cotangent equal if we were to set up and try to solve him also? Yeah, cosine over sine. Question, who would be your u if it was cosine over sine? Sine, right? So does it make sense if we were, once again, doing u sub, which we're not going to go all that crazy. But if we were, does it make sense that cotangent should have ln of sine instead? And if it makes sense to you, maybe it also makes sense if cosine is the u, there would be a negative for the du of cosine. Whereas if sine is u, if we were to go ahead and start doing this problem, if u was sine, would your du be positive or negative? Positive, right? The derivative of sine is positive cosine. So that's why this one is a positive. Okay? So anyway, forever card number 43. Yes, it is kind of tricky, but there are reasons behind the rules and where they come from. Now what we didn't get to look at yesterday was the integral of cosecant and secant. Now they're harder. They're definitely harder. Let's go ahead and peek at that really fast. Okay, we figured out where the integral of tangent comes from. It kind of goes along with where the integral of cotangent comes from. So where on earth does cosecant and secant come from? Let me go ahead and go forward a page and add one more page. There we go. All right, let's go ahead and take the example of how would we think about integrating cosecant of x? How would we go about integrating cosecant of x? Any ideas? Yeah, we could think about 1 over sine. It's not a bad idea. That's kind of what we were doing with the other ones, right? But now what? I guess we could try to think of u. U would be the innermost, right? Okay. So if we were to choose u to be sine, who would be your du? Uh-oh.
Yeah, just cosine of x.
That's it, right? Just cosine of x dx. So we could go ahead and solve for dx. Solve for dx, which is du over cosine. But if we keep on trying to go this route, we're going to get 1 over u times du over cosine. Aw, stink, kiddos. Are we in some trouble? Well, then maybe we need to go ahead and go solve for x. Do we want to solve for x? To solve for x, we have to do sine inverse of u. We don't want to put a sine inverse in there. That's going to be awful. Now, there is a trick. It's actually a CalcAB trick, which, praise the Lord, we don't need to actually figure out, because we're just going to memorize that forever card, hopefully, and not need to do all of this work, because this is showing you the behind the scenes of where this guy comes from. But technically, we could be super snazzy and say sine of an angle equals opposite over hypotenuse. We can actually set up a little triangle with our variables and say sine of an angle, x would be the angle, equals opposite over hypotenuse. And technically, we could be super snazzy and use Pythagorean theorem to solve for that third side. It'd be c squared minus b squared, or 1 minus u squared square rooted. Which is kind of crazy, but it's Pythagorean theorem put into practice. We could make that triangle. And why am I making a triangle? How could we find cosine if we know a triangle? Yeah, we could be super snazzy and say cosine is equal to adjacent over hypotenuse. So we could actually go ahead and make the substitution. It's just a crazy way of doing it. And we get 1 over u square root of 1 minus u squared du. But now some of you guys are looking and saying, how do you keep going from there? We have to actually do some math that we're not quite ready for. Some of you are maybe seeing like, hey, I think maybe I can choose this, and we'd have to do like a v substitution. 1 minus u squared, and we could keep going from here and see if it works out. V is what if 1 u substitution was not enough and we had to keep going. We could actually keep going. But do you guys see how this is a very involved process? Right?
Yeah.
So even though sine over cosine and cosine over sine were able to be solved fairly quickly with u sub, so even though tangent and cotangent could be solved other ways that we know how to do, and we know how to do fairly quickly, we said yesterday maybe it'll be easier just to memorize those two. Can we just agree for 4 and 5 it'll be way easier to memorize if we don't even necessarily know how to keep going? You know what I mean? So let's just say, hey, it's a forever card for a reason. Hey, it'll save us so much time. But these ones, if we get stuck, we can remember, oh, wait a minute, it doesn't seem to be matching. We can think about who they are. We can say, oh, that's right, it's U sub, and it becomes LNs of the denominators. And then these ones, if it doesn't match up, when it doesn't match up with our basic rules, I'm just drawing lines all over my paper. When they don't match up with the basic rules, don't make up something, it's an LN. And once again, kiddos, don't these kind of come in pairs? Aren't they kind of similar? Cosecant, cotangent always go together. Secant, tangent always go together. What's different is now we're adding. The C's have a negative. The non-C's have a positive. There's a lot of ways of studying them, but this especially is a forever card that your brain does not naturally understand or even like. Okay? And we're going to have to make sure to get it memorized because, long story short, most of you would get lost on this integral. And I have to keep showing you harder math. Okay? So let's skip that and let's say, you know what? Memorize. Let's go see some examples. What's going to be going on in this section? Which I started, I apologize. Yesterday got me a bit distracted. I started making homework for 4-6 this morning. Sadly, Algebra 1 kind of comes before you guys in the sense that I have to get ready for their class today because Algebra 1 is just so fun. It is. I like Algebra 1, just it's more prep and it's more time. But I will make sure to have all of 4-6 homework in by after school. We'll say in by 3 o'clock. Lauren, keep me honest. You need to do it during period 7. Okay, so that homework will be up by the end of period 7. But what you're going to see in that homework is a lot of division. Let's figure out how to handle division. Like, number 1. We could think of it as 10x to the negative 1, and based on what you guys are doing, a lot of you would think of it as 10x to the negative 1. And we could go ahead and pull out that 10. Guys, this is indefinite, right? No need to worry about bounds. But the problem is, if you go to use the power rule, adding 1, you get x to the 0 over 0 plus c, and you're wrong. Who is this guy? ln. Pull the 10 out. 1 over x, we need to get to where we recognize that is not power rule, that is just ln. Wait, did we even need to use u sub? Go team! Wait, AP guys love this sort of thing. Don't you guys see an ln? Isn't ln something, no, you're in denial. Isn't ln something that we have pre-cal properties for? Yeah. You're still in denial. So couldn't we bring that 10 up to the 10th power of x? And wait, if a positive or a negative is raised to an even power, guys, will that ever be negative or always be positive? It'll always be positive, so that absolute value bar becomes redundant, aka unnecessary. The 10th power is going to make it positive. We don't need an absolute value. The 10th power is going to make it positive. We don't need an absolute value. Now, how on earth does that example go along with number 2? They look so much different. Unless you think, who is you? Yeah, and I'm doing a U because that's not basic, right? So, you guys walk me through. I'm a little puppet. My stylus. I'm just going to do what you guys say. Don't make me do anything bad. 3 minus. Keep telling me what to do. Aaron, focus, buddy. Ooh, that was close. Alan's been doing a great job. He's not allowed to talk because the rest of you lazy bums. Just kidding. Shy one. We'll just say that's what it is. Need to start talking. Now what?
So you do the integral.
Solve for x? Okay. If you want me to. Okay, I solved for it. Now what?
These are all for
Where?
Okay.
And then substitute
So
U.
X. No. U.
Who is it?
Bottom U.
Now what?
B.
Now what?
B on, yeah. U.
Yeah. Negative 3x.
Yeah.
Okay.
That's right. And then we also.
I know why you guys aren't talking, because you can't see. Now what?
And now,
Okay.
yeah. The X turn. What about the 3? Oh, you can take the 3. I'm so excited.
How do I solve? Tell me.
Substitute U.
Substitute U.
Or, yes.
Or put U. Put U.
Oh,
Wait, no. We didn't integrate first. Go back. Put U, and then we integrate, and then
I know, but tell me how to integrate. I'm a puppet. I don't know how
So
to.
U to.
negative 1/3
Oh, wait, no, it's gonna. Natural.
times, yeah,
Oh, values, yeah.
absolute value plus C.
Now plug in what?
Now put in U.
You guys arrived at a correct answer.
Yay.
Teamwork.
Good job.
What could have been another way of writing it? I know, you can grow
And
later.
then I would have loved over 3. Negative though, right? Oh, no, thanks. That's too much.
Wait, what? How did that happen? Why is it the same thing?
Because you put in the. Oh, you asked me.
Yeah, this one can become a this a thingy, and the 1/3 is a cube root, and the negative is put them down, right? I can't take out the absolute value because a negative can come out of a cube root, not just positives. Therefore, yeah, you got to keep the absolute values in there.
Yeah.
Do you guys see the difference as to when to keep absolute value, when not? If it's an even power, something that can only be positive, take away the absolute value bars. If it's an odd power, even, odd roots, I gotta keep the absolute value. But yes. Negative or positive even powers, negative or positive odd powers. Good question. Okay. Wait, that's not bad. That's all of homework? Oh, easy cheesy. Hold on. I'm a smarter puppet. This is secant tangent. It's a basic rule. Oh wait, I'm a smarter puppet. Times u prime. Wait, I'm even a smarter puppet. These are integrals. I need a plus c. How right am I? Wrong! I wasn't integrating. What was I doing? I was deriving, and then I forgot it. Well, I remembered it was an integral, and I put this random plus c. No. Okay, so wait, there's some basic rule, right? We just don't know it forever card very well. Oh yeah, it's not a basic one. Who is he? He's one of the new ones. Secant tangent, use that. But secant, 1 over, I need ln. ln of who? ln of secant plus tangent. Now, here's a trick though. Even if I was a fairly smart puppet, and I figured out that it was this guy, why am I, you might want to beware, why am I still wrong? Even though this seems to match my formula. I didn't think of you. Remember, we have to use u sub whenever, I said beware. We have to use u sub whenever we have an argument other than who? X. So, throw a u in. U equals x over 2. Someone from yesterday, did you figure out an easier way of writing x over 2? Exactly. The derivative is so much better. So much easier. Because instead of doing quotient rule, if you know it's 1/2 x, who's the derivative? Nice. That's what quotient rule would have found you. So then dx is equal to, remember, just solve for dx, right? How do I solve for dx? Multiply by 2. Good. Plug it in, plug it in. Secant of who? Times 2 du. Any coefficient I can pull outside. Then we have to make sure we get that forever card memorized because we should be able to make the jump to the card, which is ln of absolute value secant u plus tangent u plus c. This is example number 3, isn't it? Sorry. Okay. Very last step, what do you need to do? And u is secant of x over 2 plus tangent of x over 2 plus c. There's a 2 in front. Sorry, that's annoying. Not to us, but to you. No, not to us. What are they probably going to do? Yeah, they're going to say he's an ln. I know, they're mean, whatever. Got a deal. So we have ln of, why am I putting parentheses if I'm putting a squared in? It's redundant because a squared will make them positive anyway. Dun, 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 dun. How are we doing? Anytime the argument is not just x, we have to do u sub, right?
Yes.
And we just saw that there are some new rules that have appeared that we have to learn and memorize, or else we're going to get a little bit lost. Wait a minute. Hold on. The next example looks drastically different. Are we back to division again? Yep. We're going to kind of like bounce back and forth in homework. I think most of the beginning is division. The next section comes in these funny rules that we have to memorize, the new ones. And probably a bit more division. So what's going on with this guy? I'm not even going to say anything because you guys have done a lot of these. I just want to hear what you would think of. Then I'm going to say what's good and what's bad, what to keep and what to throw out. And we'll figure out how to solve it. So what would you think of doing? Factoring? Okay. So let's see how the factoring works. We have 2x, x, 3 and 1. Ooh, that looks good. We need a positive 7, so plus and plus. Wait. Oh. Hold on, so my factoring was bad, right? Couldn't I put 3 and 1? So I need to get 3. I need to get 2x squared. But isn't that going to be 2 and 3 makes 5? That's even worse than the other one. Is there any factoring possible? Any factors of negative 6 that make 7? Nothing, right guys? Because I'm not allowed to have the same sign. That would be a positive 6 and I have a negative 6. So the only possible options are 2 and 3 and 6 and 1, and none of the signs are going to make it work, right? Nothing. Alright, well factoring was a good idea, and actually to be honest, that should be your first thought, but factoring didn't work. Aww. Now what? Okay. If you want, you can put your pencil down and let me try it. That sound good? We could try the heart, but the problem with the heart is that there are going to be 3 yucky things, right?
It's a claw.
Remember, we can have a multi-pronged heart. We'll say it's doctor's heart. Anyway. Just kidding. But if we were to write that, I think you guys notice it would still be pretty nasty. We'd still have some problems, right? That doesn't necessarily seem to help things. Okay. The heart is a good idea, but not a good 1 for this problem. So let's try u. Who would you think u is? Yeah, right? But what's going to be an issue if we choose x minus 2? How's his du look? Like it'll cancel stuff out? Uh-oh. If you want, you can keep your pencil down and let me try. We end up with dx equals du. Well, that's exciting. Not really. We end up with x equals who? I'm doing integration on crack because I'm like, I don't know, there's a lot of stuff I gotta get rid of. Ooh, thank you. Then I would go plugging in. I would get 2 times u plus 2 quantity squared plus 7 times u plus 2 minus 3 all over u du. How fun does that look? Yay! Could we FOIL and multiply and distribute and then combine like terms, then do lots and lots and lots of hard methods? Yes. Do you want to see an easier approach and the thing that I want you to always see whenever you see an improper fraction? Wait, improper fraction. Whose degree is stronger in this guy? It's top heavy. Like 5 over 3 is top heavy, right? Isn't that a whole number and a little bit more? 27 over 4, that's top heavy. There's a whole number and a bit more. Whenever you see a degree on top stronger than a degree on bottom, he's top heavy. And we can pull out somebody that's a whole number or a whole polynomial and a little bit more if only we could break him down. What am I doing? Old school, long division. Factoring didn't work, but it doesn't mean that I still can't break it down. Synthetic? Not always, because remember, we're not always dividing by a linear. Like an mx plus b, if it was an x squared, synthetic would be illegal anyway.
But your synthetic is legal.
Yes, but I show the general method that always works. Is that cool?
Yeah.
Okay. X within 2x squared, 2x times. Wait, didn't we practice this for a week asymptotic days this year? Ah. Just saying. And last year in pre-cal, we talked about improper fractions, breaking them down too. Remember, how do we multiply? Distribute, right? So we have 2x squared minus 4x. It's a division problem, which means, what do? We subtract, which means we change both the signs, right? We end up with those cancel. 7 plus 4 is 11. Oh, I'm stuck. Oh, not. How many times? 11. Look at the outer terms, right? Plus 11 to keep it the same. I get 11x minus 22. Subtract means switch both the signs. I end up with the remainder of, and how do I show this mathematically? Exactly. So let's go ahead and say that was all great legwork for what we need to do. Where can I move him? Basically nowhere. All right. So here's what I'm going to do with that work that we just showed. I'm going to take this integral. I'm going to say, hey, you know what? He's the same thing as the integral of 2x plus 11 plus 19 over x minus 2. Why is this so much nicer? How's 2x and 11 to antiderive? Not bad, right? The 19 over x minus 2, uh-oh, I gotta do some stuff to him. I'm gonna pull out the 19. Remember, for integrals, we can do it piece by piece, and I put those together because they're easy. He's separate just because he's hard. Just a method. Be careful or beware of stopping to write things. You're like, oh, that's easy, I'll get back to it. When you're busy, when you're working hard, when there's a timeline, a deadline, we tend to forget what we're supposed to remember, right? So make sure you keep writing stuff. Like you could go ahead and integrate this and get x squared plus 11x. That's good, right, for this guy? 2x squared over 2 plus 11x. Plus c, I don't need a plus C yet, because aren't I getting a plus C from this guy? Okay. Question, how do I go about integrating this guy? Gotta have him. Who would you guys make your U? Good. So we can make our U sub. du is equal to derivative of x minus 2. It's just 1, yeah, dx. Or dx is equal to du if we were to solve, and that doesn't really make a difference, right? So now we gotta go about actually solving. So we have x squared plus 11x. Don't stop writing them. Your brain will probably forget. If not now, then in the more intense situation of a test. How do I integrate? Oh, that's why. That's why, right? Who is that? ln. Whenever you have an improper fraction, it is very common to have a piece, at least one piece, that needs an ln. It's very common to have a piece, at least one piece, that needs an ln. My last step is just plug it in, plug it in. And if you guys notice, let me write it. If you guys notice, if I bring that 19 up, remember how we were doing log properties? If I bring that 19 up, it's going to be an odd power, bless you. Is that going to help us take away the absolute values? No. So for this one, let's just say, you know what, every now and then the AP guys might leave it. We'll just leave it this way for now. Dun, 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 dun. What was the key? Long division. When do we, off to the side, when, you guys know INT is integrating, right? When integrating improper fractions, rational functions that are top heavy. I'm going to say improper functions because it's not just a fraction. When integrating improper functions, you must do long division first. And you guys might have written this down below just because I was out of room. I went ahead and wanted it on this page and wrote it off to the side. But when integrating improper functions, you must do long division first. This one, there actually was a way to do it if you hadn't done long division, but as you guys noticed, it was messy. Some other ones are literally impossible without the long division, so just be careful, okay? All right, we've seen ln come up in lots of different places. We've seen them in like fractional stuff, like in the last page with example 1 and 2. We've seen them with the trig rules that are not basic. They're harder and we have to memorize and use them. We've seen them with improper fractions, right? So question, what if I was to give you, we already did those ones in another section. We might peek at a couple of these tomorrow, kiddos. You've been seeing these in homework. Oh, we were supposed to grade homework. That's okay. It's Wednesday before gone today. Since I've given you so much grace on homework, I might keep you accountable because homework should definitely be done tomorrow. Section 4.5. Accountable? What? Grade? What? Make sure you have your homework here and ready to check tomorrow since I've given a lot of grace. It better be done. 4.5. Better be done by tomorrow. However, kiddos, sorry, this stuff is not in our 4.5, the B to the U. We actually already covered this. So we're not going to stress about the rule, but tomorrow we might just peek at a couple examples to make sure you guys are doing all right with the E to the U's or the B to the U's. It gets a little hard. But otherwise, kiddos, we're done with section 4.6, and I just said those are not even in your 4.6. That was in the old 4.6 equivalent. So to end today, let's peek at these two. Let's peek at these two. Ooh, these are, What's going on with these guys? Your pencil, what? What's going on with these guys? Which one looks harder? A or B? Exactly. B, theoretically, if we do long division, it'll get a whole lot nicer. So it does look bad, I agree. B looks bad, but long division is going to make it nicer. A, what do we do? I don't know. Let's start. Well, we can't do a basic rule, right? We can't like split it up by dividing because as we learned the other day, can we do an upside down heart and split stuff up? No, that denominator is unable, illegal, upside down hearts are bad. I say sacrilegious for math. The denominator is tied. Well, if it's tied together, I guess there's only one thing to do, and that is who is you. Alright, I'm going to focus on him for a while. Ooh, it looks all like blurry now. That's not fun. Ignore B. Who's you? Well, I don't know. I guess everybody, huh? Okay. Stink. Who's DU? You might need to rewrite this guy to help you take a derivative, right? Some of you, it's been a little time. You're a little rusty. I'm just showing all the work to make sure we get it right, yeah? Why do I have a times before my dx? Don't kill a bunny. Take the derivative of the outside, keeping the inside the same, times the derivative of the inside. You guys get the time too? Times 2? Don't worry, some of you guys, it's been a while for deriving. We're still getting back in the hang of things. 1/2 u to the negative 1/2 times u. Okay, hold on, let's rewrite this. This is messy. Don't the 2's reduce? Okay. And this is the same thing as 1 over square root of 2x, right? Dx. Then we solve for dx, and what do we get? Good, square root of 2x times du. Now, just because we've been all over the place, let's remind ourselves that's u, and that's dx, right? Okay. Let's zoom out a little bit. It's time to go plug in. So we have the integral. Let me make it black so it sticks out. The integral of 1 over who? U times square root of 2x du. Wait a minute. Are we allowed to integrate right now? No. Because we still have an x in there. Wait, what do we always do when we have an x that's stuck? We go do the crazy integration, right? Go solve for x. So coming back. Ew. Maybe I don't want to solve for x. Who could I solve for instead? Couldn't I just solve for the thing I need to plug in for since it matches? Couldn't I just say that's u minus 1 and use that substitution? You guys see it? It just makes life a little easier. Think outside the box a little bit. We just need to plug in. So now we can make this the integral of 1 over u times u minus 1 du. Ugh. Wait. Don't integrate yet. There's no product rule for integration, but what can we do? Yeah, combine it. Can't we just distribute? Okay, cool. Who's u over u? 1. Minus 1 over u. Oh, finally. Is that somebody I can integrate? Yeah, it is. So let's go ahead and say, sweet, what's the integral of 1? In terms of u. U. Minus the integral of 1 over u. ln, right? Are our brains jumping there yet? ln of u. Let's see. Don't kill the poor little baby red panda. Then we say, alright, it's time to plug in the mess. And the mess is not pretty. But the mess is right. Oops. Wait, question. Why am I gonna write it one more time, but this time taking out the absolute values? Why is it redundant this time? 1 is always positive, and the square root is written as a positive. What's a positive plus a positive? Positive. I don't need to worry about the absolute value. It's redundant yet again. Whew. Well, that one was a party. But when we were doing our use sub, guys, wasn't it just staring us in the face that we had to go back and figure out something else to plug in? Right? Otherwise, how would you solve that? I don't know. Now, we don't have time to do the next problem, but I just wanted to show how would we do the next problem. Long division first. Kiddos, we are checking 4, 5 tomorrow. We should technically be checking 4, 6 tomorrow, but we'll save that one until Friday. But technically, 0x. Technically, we are done with 4, 6 besides a couple review problems that actually have very little to do with the homework. So, you kiddos, be working on 4 and 5, but you should be done. Start on 4, 6. You'll have tomorrow night to do a little bit more. Bye guys, tests are coming.
God.
Test is next Friday, right? Or sorry, Tuesday.